Today is Thursday, January 10th, and we're doing Eureka Math Module 3, Lesson 11. And your learning goal says, I can use what I know about equivalent fractions to subtract fractions. So in your head, you can probably predict that we're going to be following those same steps we usually do, except at the end, instead of adding, we are going to be subtracting. Very good. So this review is reminding us that when we subtract, we always need to be working with the same units. In this first problem, the red one, what kind of units do we have? Apples. If we have 5 apples and we take away 2 apples, are we working with like units? Yes. Then we can subtract. If I have 5 apples and I take away 2 grapes, do we have the same units? No. We can't subtract. In the blue problem, what kind of like units do we have? Sevenths. Very good. What about in the black colored problem? Sevenths. So this is a reminder that just like addition, when you're working with fractions, you need to subtract using like units. Okay? When we're working with these fractions, 1/3 minus 1/5, are we ready to subtract yet? Why not? We don't have like units. What units do we have in our first fraction? What are the units here? Thirds. What are our units in the second term? Fifths. Thirds and fifths are not the same thing. We need to follow those same 3 steps to subtract. So the first step is going to, again, be to find the least common multiple in order to turn that into the LCD, the least common denominator. So what's our first number that we need to skip count for? Everyone? 3, because our first denominator is 3. Okay? Let's skip count by 3s and write it out. Ready? Go. 3, 9, 12, 15. We know we can stop because how many times did we skip count? 1, 2, 3, 4, 5. We know that 3 times 5 is 15. So for sure, that's going to be common. We just aren't sure sometimes if there's one that's less than that. Does that make sense? Okay, nice. The next denominator we have is 5. Let's skip count by 5. Ready, go. 5, 10, 15. Oh, do we have a common multiple? Yes, we knew we would. 15 turns out to be our least common multiple. That means that our LCD, our least common denominator that we are going to be using is 15. You got it. Now we need to rewrite those fractions using equivalent fractions. Okay, we've done this so many times. Our first fraction was 1/3. I know I can multiply 1/3 by some version of 1 so that I can write an equivalent fraction whose denominator is our LCD, or 15. What version of 1 do you propose that I use? Lucas? 5/5, which tells us that 1/3 will be equivalent to how many 15ths, Lucas? 5 15ths. Terrific. Let's try the next one. 1/5 can be multiplied by some version of 1 so that I end up with an equivalent fraction using the units 15ths. Aradna, what version of 1 should I multiply by? 3/3, which tells me that 1/5 is equivalent to 3 15ths. Very nice. Now, instead of doing 1/3 minus 1/5, I can rewrite that fraction using my equivalent fractions. I know that 1/3 is equivalent to 5 15ths, and 1/5 is equivalent to 3 15ths. Now, all of a sudden, it's so easy because I have like units. If I had 5 15ths, and I take away 3 of the 15ths, how many 15ths do I have left? 2 15ths. Very nice. So my final answer, 1/3 minus 1/5 is 2 15ths. So sometimes we might run into mixed numbers. When we run into mixed numbers, there's 2 different methods we could use, okay? And I want you to write this down. First copy the problem and then write method 1. Rewrite the problem using common denominators. Well, we know that we have 2 different units, 4ths and 5ths. So let's figure out what our common denominator would be. 4, 8, 12, 16, 20. And if I count by 5s, I have 5, 10, 15, 20. What would my least common denominator be? 20. So let's rewrite those fractions. 1 3/4 is the same as 1 and how many 20ths? Think to yourself, what am I multiplying by to get from 4 to 20? I'm multiplying by 15? No. What am I multiplying by? 5. So I want to multiply 3/4, think in your head, 3/4 times 5 over 5, that's the version of 1 I want to use, is 15/20. Does the whole number need to be multiplied by 1? It could be. What's 1 times 1? Okay. And then what's 3/4 times 5/5? 15/20. So let me ask you this time, would you like 1 3/4 piece of chocolate cake, or would you like 1 15/20 piece of chocolate cake? They are literally the same amount. Yes? Okay, so now we did that. Okay, now our next fraction was 3/5. I could also multiply that by some version of 1 to get a denominator of 20. What version of 1 should I use, everyone? 4 over 4, which means that 3/5 is equivalent to how many 20ths? 12/20. Okay, so now, Luke, how can I rewrite this problem, 1 3/4 minus 3/5, using common denominator, since that's method number 1? 15/20 minus 12/20. Okay. Luke did an awesome job making a fail. And then he turned into a fabulous fail. What did you forget, Luke? You forgot the 1. How easy do you think that is to do? So easy. Why? Because we're so focused on the fractions. Don't forget the whole number part. Okay. Let's ignore the 1 for a second. If I had 15/20 and I take away 12 of them, how many do I have left? 3/20. If I have 1 15/20 and then I take away 12/20, what do I have left? 1 3/20. So for method 1, whenever you see a mixed number, you can just do the same thing. You keep it the way it is and you turn it into common denominators. Does that make sense? Very good. Okay, method 2, we are going to convert those numbers into improper fractions. We know that 1 3/4 is the same thing as 1 plus 3/4. Do you agree? Instead of writing 1, how can I write that as a fraction? 4/4. So is 1 3/4 the same thing as 4/4 plus 3/4? Is it? Okay, so that means that 1 3/4 is the same as how many fourths? 7/4. Okay, so now I could rewrite this question. Instead of 1 3/4 minus 3/5, I could do, that's 7/4 minus 3/5. Do you agree? Isn't that the same thing? Isn't 1 3/4 the same as 7/4? Okay. Now, we still don't have like units, so we still have to make like units. We knew from our work before that our LCD is going to be what? 20. Okay, so now let's make equivalent fractions. 7/4 times some version of 1 is going to give me an equivalent fraction where the denominator is 20. What version of 1 should we multiply by? Everybody? 5 over 5. That means that 7/4 is equivalent to 35/20. Okay, our next fraction, 3/5, we already know if we multiply it by 4 over 4, we will get 12/20. So now let's rewrite that question. Instead of 7/4, I can write 35/20. And then instead of 3/5, I can write 12/20. If I have 35/20 and I take away 12, how many do I have left? 23/20. Huh. What do we notice about 23/20? That's an improper fraction, huh? How many 20ths does it take to make one whole? So if I take 20 20ths out, I'll have one whole and 3 20ths left. Did we get the same answer using method 1 and method 2? Yes. There are some times when method 1 will be easier, and there are some times when method 2 will be easier. There are some times when method 2 will be very complicated, and then you should switch to method 1. There's sometimes when method 1 will be very complicated, and you should switch to method 2. Does that make sense?